Okay, now it's recording. And
Okay.
okay, let's go. 3, 2, 1.
Hello, we are the Municipal Paper Recycling Plant, otherwise known as Team 19137, and our mentor for this process was Caitlin Snitzer. So here's our group photo, and introducing ourselves from left to right, I'm Isaac Mendoza, majoring in chemical engineering.
I'm Hernan Oviedo, majoring in chemical engineering.
I'm Henry Nordbrock, majoring in chemical engineering.
I'm Mohammed Aladwani, majoring in chemical engineering.
So, background. Approximately 30,000 tons of paper are thrown in the landfill every year. This material is recyclable. It is possible to pulp it, screen and de-ink the pulp, and roll it back into solid paper. Our goal as a team is to design a recycling plant that can handle that 30,000 metric tons number. We also want to achieve true recycling and by returning a product that is of the same quality as the waste paper that went in.
So looking into the design, assumptions, and modeling that were used in creating this process, after analyzing our process, the daily production rates are as follows. It was around 47 metric tons of paper per day and 12 metric tons of cardboard produced per day. With this output rate in mind, operating the plant at this rate would require around 622 kilowatt hours per metric ton of raw material. The main assumption that went into creating this process was that the input paper would be well sorted and that all large contaminants would have been removed. This would entail that maybe a few small residual contaminants were remaining in the papers or cardboard that we would deal with in this process. And separate and identical processes were created for each material in order to maximize operational continuity. So this process would seamlessly last throughout the year. And this was also in order to aid any or negate any effects of cross-contamination between either material. A tool that we used in aid of creating our process was simulating these processes using Aspen Plus.
Okay, so this is the process flow diagram for our paper recycling plant. So the beginning of our process is going to consist of raw material going into a pulper where water is going to be added to it. The material is then created into a pulp, which is then pumped into a centrifuge. The centrifuge will remove most of the solids that are unwanted in the material. Once that is removed, it is pumped through a screen where it'll remove the rest of the solids that are unwanted, such as staples and glue, pieces of glue. Once those solids are removed, the pulp will then be pumped through a belt press. It will go through a belt press where most of the water is removed so that it can then go through a grinder. Once the material goes through the grinder, it is pumped and then goes into a heater where it'll be heated up to 50 degrees Celsius and then combined with another stream of water that is also heated up to 50 degrees Celsius. Once the materials are combined, they will go into a flotation vessel. Inside the flotation vessel, we add surfactants so that we can remove most, if not all of the ink from the pulp. And then the pulp is then pumped into the paper machine. Inside the paper machine, we add 3 chemicals, the dye solution, the antifoam solution, and the aluminum sulfite. And these chemicals, what they do is they improve the characteristics of the paper. From the paper machine, we have 2 streams. One that is recycled, which is going into dissolved air flotation cell. In that cell, water is removed and then stored into a tank where we will be using it later. And the surplus sludge from the dissolved flotation tank gets recycled back into the paper machine. And once this process is done, the material is heated up to 120 degrees Celsius. It goes through a roller where it is pressed into flat sheets and then cooled back down to room temperature. And then our end result is solid paper for our products.
For the economic analysis part we did for this process, we figured out the total capital investment needed to actually build this plant in Tucson, which was around $8 million. We also figured out how much would it yearly cost to produce the paper and cardboard, which was around $11.7 million per year. Our sales, total yearly sales, were estimated to be around $8.7 million using the prices in the current year, 2020. It's also worth mentioning that the plant will never be profitable under the current prices of recyclable material due to the recent Chinese embargo on recyclables, which has decimated the prices of recyclables comparing it to last year. If we use pre-embargo prices, the plant will be profitable in around 9 years. Prices 1 year ago were around 1.6 times the current prices, so 60% more than what we currently are using. We also, using the chemical analysis, came up with some conclusions and recommendations for this process. We concluded that the project has a relatively low capital investment cost and a high total yearly production cost because of the energy, and very low yearly sales because of the Chinese embargo. Our energy usage for this process is relatively high compared to other recycling plants, and we require more research in needing to lower the energy cost and usage throughout the whole process. To make our plant successful and profitable under the current climates, the economic climate, we would require city, state, or federal financial assistance until the prices could recuperate and fix themselves in the near future. Other than that, we don't see any issues in implementing this process in real life.